Hello, folks. I am really sorry that I'm not going to be able to be with you. I had an accident a couple days ago, and in particular, I dislocated a shoulder. It's been put back in place, but when you do that, you stretch the ligaments and so forth around it, so you need to keep the arm and shoulder pretty immobile to allow that to heal. So not able to travel. And as things go, it was in my right shoulder, and I'm right-handed. So that's sometimes the way things go. I really was looking forward to the meeting here. It's a great program, outstanding group of people. I was looking forward to both catch up with old friends, but also to meet new friends and so forth. So I know you're going to have a wonderful session here. What I'm looking to do is to make some comments and try to give you something to think about. So with that, let me get the things going here. So I'm going to start off with, as I say, a high-level analysis of the global water situation. And this is really the sole slide. I'm going to take a little bit of time talking through this, but the circumstances that I believe we're faced with as we go forward. I have to say that basically I'm an optimist, but we do need to understand what we need to do. So I start off with the first one here. It says, there is no more environmental water. What I mean by environmental water, of course, is water that we normally take out of the environment. So basically surface water and groundwater. And overall, the statistic is, at least one statistic is that the available renewable water supply of the planet is about 6,000 cubic kilometers. Kind of an interesting number, but we are very close to, on average, that is our withdrawal on a global basis. Some places more. We know that particularly here in the Southwest, we know that very much for groundwater. But there's a few places where there's some additional water, but not many. Now, with that bad news, the additional piece of bad news is that climate change is altering and reducing the availability of renewable water resources. So basically, we don't have what we thought we had. Let me say that again. We don't have what we think that we had. There's some consequences for that. And the other thing is the quality of the existing water supply is also decreasing. So what that means is not only, for existing demands, we will need to be replacing existing demands, even though they're not available in terms of renewable water resources. Different situations, certain local situations, this is not quite true, but overall, this is true. So you look at what is happening in Southern California, in the LA Basin with the indirect potable reuse projects that are going forward there. This is exactly what they're doing. They're replacing imported water, but water that they don't believe that they can rely on as they have in the past. Water demands are also increasing. So we used to talk about growing population, although this is moderating significantly, but it's basically the standard of living that drives increased water demand. A rule of thumb that some use is that the increase in water demand will increase at about half of the rate of the growth of the economy. And this, of course, is in constant dollars. So if the economy is growing at 3%, the water demand will grow at about 1.5%. So, so population is becoming less significant, except for there certainly is relocation of population both in and out. So increased standard of living related to the economy. There's increased need for agriculture. Overall, this is related to population, of course, and of course, industrial growth. And here in Arizona, of course, you have data centers and semiconductors and other things, and these demands need to be met. The new water supplies are going to be provided by what some call manufactured water. So water that we create out of in other means. So certainly conservation, rainwater capture, but principally this is water reuse and desalinization. Now, I'm sure Paul is out there and he's saying, wait, there's also atmospheric water capture, but kind of looking at what's developed and available to us. So sorry, Paul. Third, the economic value exceeds the cost of service delivery. Been economic analysis after economic analysis, and when you look at the broad benefit expressed in economic terms, it's about 5 times the cost of water service delivery. The challenge is accessing the relevant revenue sources because the benefits are very distributed. Public health, the economic growth, families, recreation, things like that. But what you do see where water problems are being solved is where there is economic development occurring. So I would submit that this is a key in terms of identifying where we are going to be able to address our water problems and looking at economic development very critically to not only meet the needs of the development, but the broader needs of the water sector in that region. So money is there, we just need to find it. It's a matter of accessing the value of water in a sufficient way to fund it. Depressing, right? But the last thing here is that we've got a lot of tools. We're seeing a real renaissance in terms of the tools available to us. So certainly potable water reuse and desalinization. I've mentioned membranes, electrochemical processes, one thing after the other. So we actually have the tools, but we need to increase the pace of development and particularly implementing these, getting them out into practice at a much faster rate. So this is solvable. Our water problems are solvable, but we have to look squarely in the face of what we're faced with, and we need to make some changes. So I've been talking with the water profession for quite some time, and I've kind of historically boiled things down into 3s, mostly because the psychology is people can remember 3 things. The 3 big things, but let me go through them with you. And then after this section, I'm going to add a few more. So the first one is, the important word here is we. We as the water profession must fundamentally change our approach to water management to avoid water stress. Water stress are droughts and floods. Not when we don't have enough water and when we have too much. This concept that I'm going to describe has been phrased as one water in the past several years. Some are calling it the circular water economy. In China, they call it the sponge cities. So it's a portfolio. That's the key concept, is it's a portfolio. That phrase and that concept coined by the Australians as they were experiencing their 10-year, what they call the millennium drought between the mid-1990s and the mid-2000s. The issue is a water supply portfolio is just like a financial portfolio, different assets that function well under different conditions. You can read faster than I talk, so you've read through these. So reclamation and reuse is very valuable during a drought because you have water. It's just a matter of capturing it. When it's raining like crazy, surface water and so forth might be the best answer. So it's about in a given local condition for the current and projected conditions, putting together the right combination. We talk about resilience. This is how you get resilience in the system, the ability to function under a range of conditions. For flooding, it's the same idea, just different components. Still a portfolio. So still conventional dikes and drainage and pipes and levees and all those kinds of things. Rainwater capture fits into this to a certain extent, but green infrastructure, as we're beginning to look at in an increasing fashion, the question here, one of the nice things about, and this is large scale green infrastructure, becomes a matter of when the rainstorm is high enough that it defeats the dikes and the pipes and so forth. Where do we want the water to go? Where do we design our system so the water will go, so we can convey or store it, and that function can be returned to normal use very quickly, which is when natural systems become very attractive to that. We also need to move people out of floodplains. And that is beginning to happen as well. So you see the integrated components of this portfolio to get not only meet certain benchmarks, but to get increased resilience. It really means moving to a strategic way of looking at it along with the analytical side. Eliminating the bias, water reuse. So bringing these options to an equal basis. So if we need more water, let's think about reuse at the same time as we look at getting water different places out of the environment. And wastewater, we don't have to discharge it all. We can think on an equal basis about reuse as options, eliminate the bias. And we are moving forward with the incorporating green infrastructure and so forth. A lot of learning has happened, but a lot more learning needs to occur here to get us where we need to be. Number 2, water management must become much more resource efficient to sustain into the future. What you see on the right-hand side is one of the more recent diagrams from the Stockholm Resilience Center, where they're basically looking at because we only live on one planet Earth and we're trying to use 2 or 3 where we're overdoing it. The point here to make first is that of all these areas, water affects all of it. The way we manage water, even like things out in the natural environment where we just take too much water out, we dry things up. The RLC is probably the poster child for this, but we've got plenty of those here in the US as well. This can be looked at as kind of a moral and ethical, but there's a very practical side of this that deals with scarcity. So the line that you see, the vertical line you see on the right-hand side of this diagram pointing back is because this was a very level graph going back 100 years. What's shown here is the relative price of many commodities. So you see energy, natural gas, metals, and so forth. The reason the cost didn't go up, it's because we had plenty and we actually were getting better and better at taking it out of the environment. The chaos that you see, the economic chaos that we've all experienced in the economy, is caused by scarcity. We've reached scarcity on these things, and now that introduces chaos into the environment. So if you're a water utility and you can produce all the energy that you need, you're at zero purchase. The rest of the world can go off and do what it's going to do, and you can do your job in a reliable, providing that water service. So there's practical aspects of this as well. There's a variety of products that can be and are produced So water, energy, nutrients, organic matter. We've been doing this for a long time. We're expanding this in other areas. These are all things that are moving forward. And there are folks that are working really very much at a leading edge in terms of higher and higher value products. And you see a progression of that on this pyramid on the left-hand side. These are actually also smaller volume products because basically we've been in the commodity business. A lot of stuff that's pretty inexpensive. Moving up to higher value products allows us to contribute to a greater extent, but also can help us from an economic perspective. So just a glimpse at what, and people are working on these things. Every one of these things are in pursuit at one location or another. We also can look at changing our practices, and I want to speak here about wastewater separation because it creates energy and nutrient recovery options. We're just reducing, reducing the entropy in the system. We create entropy when we mix these things together, and the nutrients. There's a lot of nutrients in the wastewater stream. They're in the urine. Nitrogen, phosphorus, and potassium. 1% of the flow. 1% of the flow. There's chemical energy here in the organic matter, both in the fecal matter and kitchen waste, if you dispose of it that way, manage it that way. Again, in a small volume. This is chemical energy that can be recovered. Then the gray water is where most of the water is, and it's much less contaminated. So if we keep them separate and deal with them, we get advantages both in terms of the energy that was needed, but we can recover energy and nutrients. We've got the technology to do this. This is really people and institutions. It's really dealing with people and institutions that get us there. This is yet an under-realized advantage for us and needs more emphasis and more investment. What's our other issue here? So recovered material is a resource only when it is used. So recovering a little bit here and there and here and there doesn't get it into use because it must be delivered to folks that actually will want and use it and ideally pay us something for it. So it has to be in sufficient volume for the user. The delivery needs to be timely, and it has to be in strict compliance with their product requirements. This is a way to think about this was something that I actually had Mark Van Loostrick was the first one to say this, at least that I'm aware of. And it really resonated with me. He said, I grew up on a farm. It was a pig farm. But my brother married a farmer's daughter, and he spent 30 years with the family, running the family dairy farm. So you see, the milk that my brother Dale was producing on his farm, sitting in a tank at the farm, had zero value. What created value was that aggregating Dale's milk with 99 other farmers in a cooperative so that there was the scale to turn that into whole milk and skim milk and cottage cheese and all the different products, and the relationships with supermarkets for some that would buy it. This is our missing step. How do we achieve this? This is really about getting appropriate scale. So I think the collaborative is one example here. We need leadership by our large utilities and the large water companies, and potentially collaboration with the private sector here. So this business side is something that we really need to be working on. You know how to do these things? It's a matter of, first of all, putting everything on the table. Consider all the options, and that this list is just trying to be, it's not fully exhaustive, but to give the range of things. Put them in together in systems then. There isn't a silver bullet in terms of one thing that's going to turn this around, but we do have we have a lot more ammo in our arsenal here. Then we need to put it together in the right way, both centralized and decentralized. We focused historically on centralized systems, which means that the distributed or the decentralized components are, in many cases now, some of our best opportunities. So, so it's understanding the pieces and then system thinking. Here's just an illustration to show several of these things coming together. I was in Hong Kong about 6 weeks ago, and this was something I shared with them. As I say, the distributed systems fit the form of urban development in Asia. For those of you in Asia, you know that residential developments look like this: 6 or 8 or 10 or 12 high rises, all looking exactly the same and clustered together. This is the perfect scale for distributed water management. Can still have some connection to the centralized system, but here you have enough demand to be able to do things economically. We need to be thinking this way in the U.S., where we have new development or have opportunities on a collective basis to put systems in there and to do it not just the old way in terms of treatment and discharge, but we need to look at reuse of the water, minimizing the piping and so forth, and recovery of other materials. Take advantage of the more concentrated sources, concentrated in terms of people, and use it to recover and reuse. What will these systems actually do for us? They actually improve public health. Contrary to what some think, for a variety of reasons, you increase public health here. And actually, reuse, we actually are more conservative. So you actually end up with better protection. And also from a public health perspective, by dealing with infections and so forth more locally. There's less water out of the environment, which we've talked to because of the reuse, and significantly reduced environmental discharges. The truth is that given our goals in terms of, the Clean Water Act was to produce fishable and swimmable waters. We're not there yet. We actually are not removing as broad a range of constituents as we should be. The 72 Act, the goal was to eliminate discharges. People laughed at that and you say, oh, I can't get to zero. There's another way to eliminate. It's to get to reduced volume and potentially to zero volume. Then you've eliminated it. So this solves some of our environmental water quality problems as well. Reduce resource consumption, as we talked about. Easier upgrade and expansion. You don't have to expand the whole centralized system. You can focus it where you need it. And this can give increased system resilience, the ability to adjust, and increased urban environment as you're using the local environment as part of your water management system. We need to do it. It's a bargain. Third item, human right to water and sanitation. On the right-hand side, I'll come to this in a minute, but this is a diagram out of a manual that the IWA produced. Did this during my presidency, actually, but this was right at the time that the human right to water and sanitation was adopted by the United Nations. What you see here is the dimensions of the human right. And it's just not about the technology. It's not just about the engineering. Certainly you got sufficient quantity and safety and so forth. But this radar diagram is a tool to see in the breadth of the factors that relate to the human right, how you're doing. One of the things that I actually learned from this also is that from this exercise is there's actually a well-developed legal framework for human rights and the allocation of responsibilities to various parties in terms of what is needed for a human right to be in place. I'd commend that to anybody that's looking at these kinds of issues. It is not a single party that does it. It's a collective responsibilities. But I highlight these two because these are ones which these are the two things that we do the poorest. We even do this fairly poorly in the US. Fortunately, we're starting to recognize that and making some steps, not enough yet, but making some steps. So again, part of the issue here is that the benefits of effective water management are very broadly distributed. Health, public health, economic development, aesthetics, the enjoyment of a good water environment and so forth. And again, the difficulty is then tapping into enough revenue streams to be able to finance good water service delivery. Do all the costs need to be directly funded by the customers? The answer is no, because the benefits are pretty broadly distributed. So that's one area. And also, can the cost structure reflect the ability to pay? For those that can't, can we subsidize them? The answer is yes, we do that in other areas. Other countries have done a better job of us in terms of providing a modest but defined level of service for everybody, irrespective of their ability to pay. A lot of options available. So, a lot of ways we try to do this in a short time. It took us 50 to 100 years in places like the US to develop this. We can't pay for necessarily all that in 20 years. So this is where tariffs, taxes, and transfers, other means of funding to supplement it, and even looking at 50-year bonds. DC Water was one of the first. They said, we're putting in new sewers. They're going to last much more than 20 years, so we're going to pay it back over more than 20 years. And they were very successful with things like this. You also need to understand the role of the private sector. The private sector can deliver the service. They can help get the financing, but they don't provide the revenue. People get very confused about financing, which is money that needs to be paid back, and funding, which is the revenue that is needed for the entire service. Private sector can't provide the revenue, just cannot. Demand-driven infrastructure, very nice. So Clayton Christensen he passed away recently, but he was very well known for his work in innovation. He's a business professor. In some of his last work, he was looking in Africa about where the development of infrastructure, where it was successful and not successful, because it's been a disaster in many places. The idea will put the infrastructure in and it will create the economic development. What Clayton Christensen found is that where there was economic development, that created revenue then to support infrastructure on a long-term basis, but the infrastructure needed to be right-sized to what was needed and what could be afforded. Again, this comes back to, quite frankly, one of the comments on my first slide. Proactive community engagement develops credibility and forward motion. How do we do this? And I want to go through what you see here is on the right-hand side is the cover of a very nice study that was done looking at, as it says, mainstreaming potable water reuse in the U.S. And it turns out that it is a lot of things other than just the technology. And I'm going to go through these, but part of it is strong local utilities connected with those that they serve. So there's a series of items here. We'll talk through these, but if you're looking to implement potable reuse, the first thing is to assess the utility's reputation among customers and decision makers before investing in project planning. If it turns out the utility is not credible, it's not going to go forward. It is that simple. A number of studies of successful and failed potable water reuse schemes show this very clearly. So figure out where you are. The first thing is figure out where you are. Then create and execute a comprehensive strategic communication, outreach, and involvement strategy aimed at building trust and credibility. You have to be trustworthy. You have to be credible. So if you're not, a big part of this is changing your behavior. But as you do that, work with the community, work with other parties in your community, and build this over time. To become trustworthy is real simple. You have to tell people what you're going to do, and then you have to do it. You have to be good to your word. The communication part is communicating what you're going to do, doing it, and then letting people know. There's another part of communication, though. I'll come to that in a minute. Part of credibility also is external expert bodies. What do other people do? What do we really know? Again, this is to help build credibility. Just going through what's exactly in this report. Assess community needs. You're serving the community. Assess their needs and what drives them? What do they want? Here's one of the biggest mistakes we water professionals make, is that we try to convince people that they should care about water as much as we do. We're usually unsuccessful. Turn this around, though. If we understand what the public wants, when we look at it, we find that water can help them accomplish many of those things. We don't have to get them to care about water the way we do. We just need them to understand that supporting good water management gives them the things they care about. But you have to know what those things are before you can do it. I'll tell you where utilities do this, they're very successful. So a very important point. Let's take an integrated water management approach, understanding the broad and long-term water goals and how, in this case, reuse fits in or doesn't fit. In our broader context, understand the broader water management situation and look for the things that really make sense in that context. Develop a comprehensive financing plan. So don't try to just go build something and hope it's going to get paid for. Pretty straightforward. This includes not only the capital, but the asset management and the long-term O&M. Get all those things into it. Work actively with the state primary agencies. This is reuse, but if you're looking to do, whatever you're looking to do, bring the regulators on board. Get them to be part of the solution rather than part of the problem. And introduce potable reuse as a potential water supply very early. So again, this is understand the community, build your credibility, start talking about the long-term and the options. And if whatever the combination is that makes sense, that's the answer. That's the answer. Tie it to what people want. When you do that and make those ties as clear as you can, that's how you build the support. They're not necessarily supporting water, but they're supporting water for X, which is just fine. And collaboration, you don't need an entire water cycle utility. You just need the different utilities to work together. A lot of places where that happens. A lot of places where you have a single water utility, water cycle utility, and the departments inside can't get along. So just putting everybody together is not necessarily a solution. I've talked quite a bit here about a number of things. I want to turn to natural systems because natural systems provide a diverse array of services. This is almost like water itself. When we introduce a natural system component, we not only address one part of the water cycle, but we get benefits that radiate beyond that. This is also an area of opportunity because of those broad benefits. And these are broad benefits that people care about, but by not taking as much advantage of this as we can, it's a lost opportunity. So water supply, uh, water supply or vegetation actually retains water in the watershed. So New York City, protected watershed, City of Portland, Seattle, number of places, San Francisco, the Hetch Hetchy system there and so forth. And it maintains and improves water quality. Water storage, impoundment, and aquifers. We're starting to think about aquifers and recognize them, and we've known about them for a long time. Conjunctive use of surface and groundwater is an old concept. It's being actioned at a much greater rate, but not nearly to the extent that we need to be doing this. Water conveyance and retention. So this is really in the stormwater situation. So a natural treatment system can very easily flood with little damage and increase conveyance out. And when the water, when the water goes away, it goes right back to being what it was. They're very good at things like this. Water treatment, obviously, land stabilization, erosion, landslide control, avoiding land subsidence. These are very important issues with a lot of dollars associated with it, and good water management helps us to accomplish these things and to receive the economic benefits of not having these things happen to us. Temperature regulation, both in a small and a broader perspective. Heat islands locally, but even on a broader perspective. Health, physical health in terms of recreation, getting people out and getting them moving. Very important for health, and we need the facilities to do those things. And mental health. Turns out that if you're in a hospital and if you have a window that looks out on a tree, you get well faster. Believe it or not, this really happens. This connection to nature is part of us as people, and it improves, using it improves our physical health. Just being adjacent to nature improves our mental health. And getting out with people in nature helps our mental health from a social perspective. So we're really looking now these days are resilient systems that perform well over a range of conditions and are adaptable. So I've talked through several of these things. So integrated rainwater management infrastructure, again, putting that portfolio, but especially making sure that we're integrating it with spatial planning. Let's not build where we shouldn't. And when we have, when we can, move people out. When it floods, just don't rebuild it. Portfolio of water supplies. So this is the drought side. I've already spoken of water reuse here as an essential component. Resource efficiency, the idea that there's no waste, and that we're going to minimize needed inputs. These are things that I've talked about already. Continuous restoration of the natural environment. There's a lot of benefit. There's benefit to water management. There's broader benefit to that. So returning land to nature, in valuing the environmental services that are there, returning water to the ecosystem, and managing inputs. Flexible and adaptable. When we look at putting something in place, how can we use it in other ways as we go forward? Because we're going to adjust. Credible and capable utilities. I've spoken to that already. So how do we achieve systems like this? I talked a lot, but let me get down to just a few key action items here. First is develop a vision that aligns with the physical realities of your community. There's some things that just can't be done. There's some things that are easier to do. But a vision is not a plan. It's an idea of where you can go. It has specifics, but not a schedule. Engage with the community. Do these things in parallel. Understand what the community cares about and wants to achieve. Tie that to water management. That'll help you sort out of the things that you can do, which ones you're actually going to be able to get implemented. And you do that by tying progress on your vision to achieving community objectives. They'll tell you, if you listen, they'll tell you when to do what. Maintain and expand a collaborative relationship with senior government, regulators, and so forth. Identify options that provide multiple benefits. Select based on the total value relative to community goals. Don't do things one at a time. Look for things that, 1 + 1 is 3. The other thing is, let's look to kill two birds with one stone. I would tell you every culture around the planet looks to do that. Move forward pragmatically, but consistent with the vision. Learn and adapt. Every time you take a step, you create value, but you learn and build on your successes. Actually, it's not what we need to do is not that hard to understand. We'll close off with a little bit of American wisdom, Yogi Berra. Yogi Berra once said, "You've got to be very careful if you don't know where you're going, because you might not get there." This is about having the vision. Where are we moving towards? As you learn, you adapt and you refine and so forth, but you need to know the direction and the nature of the destination. Yogi also said in theory, there's no difference between theory and practice. We can just sit around and think about things. In practice, there is. Go and do things. When you do, you learn in a way that you cannot learn in any other way. Go forward, move forward, learn and adapt. And the game isn't over till it's over. In water, we're never over. We're always adapting and adjusting. Thank you so much for your time and attention. I hope I've given you a few things to think about.